Hi! At Aspiring Minds Research Labs, we use machine learning to grade open responses. We use the power of data to grade motor skills, spoken English, and programs. This grading enables feedback and credentials for learners. Let us first define what a motor skill is and why do we need to assess it. A motor skill is simply an action that involves movement of body parts. Movements involving larger parts of your body, like in sports, is a gross motor skill. And smaller movements involving wrist and elbow, like in plumbing, is a fine motor skill. A quick look at the website of the U.S. Department of Labor tells us that 350 out of a total of 1,650 job roles require moderate to high motor skills. These include plumbers, tailors, carpenters, and machinists, among others. There are some traditional methods like the O'Connor-Tweezer test and the GATB manual dexterity scale, which measure motor skills. However, there is no definitive, reliable, and scalable way in the market to assess them and to create credentials for vocational workers. We have made the first attempt to create a standardized and a scalable way to gauge these skills. We have exploited the power of touch interface on tablets to capture various movements of fingers, arms, and shoulders through innovatively designed applications. The performance in these applications is hypothesized to be an accurate and reliable proxy to the person's motor skills. This is the first time anyone has ever used touch-based interfaces for motor skill assessments. How did we do it? First, we determined the motor skills that should be assessed. We used Fleischmann's taxonomy, which defines 52 human abilities and related skills. Out of these, we selected 4 motor skills which had empirical evidence to significantly predict job performance for various vocational jobs. These are finger dexterity, manual dexterity, wrist finger speed, and multi-limb coordination. We then did a detailed user study to find out tablet-based apps that required movement of one's wrists, fingers, elbows, or shoulders. Based on it, we carefully designed 11 applications which map these specific movements to different motor skill competencies. Let's look at an example. Our Douse the Fire app requires the candidate to use elbow and shoulder movements to douse as many fires as possible, and it measures the manual dexterity and reaction time. Similarly, we have other applications like Trace a Path, Roll the Ball, Resize, etc. These apps capture various parameters like spot, trace, pinch, and rotate. We learned a supervised machine learning model where these parameters are used as input features, and the scores obtained from the manual motor skill tests act as outputs. This trained machine learning model can now be used to obtain scores for a candidate, given the measurements from the tablet tests. To measure the validity of these applications, we ran our studies on different blue-collar jobs. We observed that our app-based scores are a better predictor of on-job performance than manual tests. The manual test scores correlates with few job performance metrics and ranges from 0.19 to 0.33. In comparison, our app-based score shows a significant correlation with all job performance metrics and ranges from 0.19 to 0.38. The correlation values of app scores satisfy the requirements to use the tablet-based test in the labor market. Evidently, this work makes the assessments for motor skills super scalable, standardized, easy to comprehend, and fun to use.